Lesson 7-1 Practice. Lines, angles, and curves. Question 1. Find the values of x, y, and z. So the arc x is going to be the same as the central angle. So it is 20. The central angle z is going to be the same as the arc y, and those would be 160. 180 minus 20. Question 2. Refer to the image. Drag each segment to the appropriate bin to classify the segment. All right, I'm just gonna go in order. AB. AB is a radius. It's from the center to the edge. AB is a radius. BC. BC is a diameter. It is a chord that goes through the center of the circle. It is a diameter. BC is a diameter. AC. AC is a radius. AC is a radius. AG. AG is also a radius. HG. HG is a diameter. It is a chord that goes through the center of the circle. HG is a diameter. DE. DE is a chord that is not a diameter. And finally, AH. AH. AH is a radius. Question 3. Identify whether each statement must be true, could possibly be true, or definitely can't be true. A diameter is a chord. A diameter is a chord that goes through the center of a circle, so that is always true. Must be true. A radius is a chord. A radius is not a chord. It doesn't go from one edge to the other. It goes from the center to the edge. Cannot be true. A chord is a diameter. A chord can be a diameter, and a chord if it goes through the center of the circle. So, could be true. A central angle measures 90 degrees. Yeah, it could be true. It may not be. Question 4. Write an equation for the altitude from vertex A. Okay, so they want us to write an equation for this line. I can't really determine the slope of that line, but I see it is perpendicular to BC, which has a slope down to right 9, -2/9. So a slope that is perpendicular would be positive 9/2, 9/2. So we're going to use this point, 2 comma 1, and the slope of 9/2. So we take y minus the y value, which is 1, equals the opposite reciprocal slope, which is 9/2. 9/2 is the opposite reciprocal of -2/9, right? Times x minus the x value, which is 2. I usually copy and paste, but I'm going to take the time to type it in. It's y minus 1 equals, I think it was 9/2 times, what was it? X minus 2. X minus 2. Question 5. Triangle ABC has vertices at 5, 0, 1, 6, and 9, 3. What is the point of intersection of the triangle's medians? All right, so 5, 0, 1, 6, and 9, 3, right? 9 up 3. All right, its medians are segments from the middle to the opposite vertex. So vertex to middle and vertex to middle. All right, you can see they intersect at right 5 up 3, right 5 up 3. Question 6. Consider the parallelogram with vertices at 0, 0, 8, 0, 4, 6, and 12, 6. Where do the diagonals of this parallelogram intersect? All right, we had the points 0, 0, 8, 0, 4, 6, and 12, 6. The diagonals are segments from opposite vertices. And you can see they intersect at right 6 up 3. Right 6 up 3. Question 7. Lines L and P are parallel. Select all true statements. Triangle ACB is congruent to DEF. No, ACB is much smaller than DEF, right? The slope of line L is equal to the slope of line P. Well, if they're parallel, they have the same slope. Triangle ACB is similar to triangle DEF. That is true. The sine of A equals the sine of D. Well, since they're similar, their angle measures are the same. So sine is opposite divided by hypotenuse. So that would be the small leg divided by the hypotenuse, right? And for this one, angle A, opposite it would also be the small leg divided by the hypotenuse. So that is true. The cosine of B, well, cosine is adjacent divided by hypotenuse. So angle B, adjacent to angle B, would be the short leg, and then divided by the hypotenuse. And the sine of D Sine is opposite divided by a hypotenuse. Again, the short leg divided by the hypotenuse, so that would be true as well. Question 8. May wrote a proof that triangle AED is congruent to triangle CEB. May's proof is incomplete. We know side AE is congruent to side CE. Okay, yeah, they mark it with those little marks. Angle A is congruent to angle C. Again, they marked angle C and angle A congruent. By the angle side angle triangle congruence theorem, triangle AED is congruent to triangle CEB. Complete the statement to explain how May can fix her proof. Well, she said she was proving it by angle side angle, and she only said that one angle was congruent. You need another angle. So the vertical angles are congruent. So CEB or BEC, those are the same angle, is congruent to DEA or AED. May can fix her proof by including a line stating that angle AED is congruent to BEC or CEB, BEC, because they are vertical angles.